everyone! Today we are going to talk about proofs. Okay, let's get started. The first problem I have in this top left corner here is measure 3 is 55 degrees. Which angles are supplementary and how do we know? Oh, I'm missing an angle. This should be a 4 here. 4, 4. Okay, so let's talk about it. First, let's find just one angle that's supplementary. Well, 3 is on that reddish pink line, so its linear pair, which would make it supplementary, is 4. So 4 is supplementary to 3 because they exist on the same line. They make up the pinkish red line. They're supplementary. They're linear pair. Okay. What else is supplementary to 3? Well, it'll be 1 because 1 has the same value as 4. They're vertical angles. Let's continue. 5 corresponds with 1. They have the same value, which means they will be supplementary to 5. Lastly, 8 is vertical to 5, which makes it the same value. 5 is corresponding with 1, which makes those the same value. 1 is vertical to 4, which makes those the same value. And 4 and 3 are supplementary. Therefore, all 4 of those angles are supplementary to angle 3. Wow, that was a mouthful. Anyways, onwards we go. Now, this type of proof style is going to be kind of familiar to those people older than you. For a very long time, we had to be very exact in these proofs. The way we're going to do it is much less exact because it's a little unnecessary these days. The way you're going to see these more often is we're going to give you proofs and we're going to have some missing areas like explanations or well, whichever side of the line it's on. So you'll see how that's going to go. Today, I'm just going to walk through the proof. We're just going to write it from scratch. So something that you would have had to do when you were if you were my age when I was your age. Okay, let's get it. Line A is parallel to line B. I'd like to prove that angle 1 and 8 are supplementary. Now I have poor lonely angle 1 highlighted already. It is the angle that kind of starts off with 1 and 8. I want to get to angle 8. Now you can see that angle 1 and angle 8 are on 2 separate lines. 1 is on A, 8 is on B. So let's try to connect A and B. The connection that I see here is between 1 and 5. Now 1 and 5, they are corresponding. What does that mean? Well, that means that 1 and 5 have the same value. They're congruent. So let's jot that down. 2. Angle 1 is congruent to angle 5 because, and I am not spelling this out all the way, corresponding. There, that's abbreviated enough. Okay, perfect. We made the connection between the 2 parallel lines. Now that I connected 1 to 5, let's try to connect 5 to 8 because we need to get to angle 8. Now take a look at 5 and 8. How are they related? Well, 5 and 8 both sit on this black transversal. 2 angles that make up a line are a linear pair, which means they're supplementary. Correct? Correct. I was just checking if what proof I'm doing. I'm confused. Okay, so let's say angle 5 is supplementary to angle 8. And we know this because they are a linear pair. This one I'll write out. Short words. Okay. Lastly, Lastly, I can right away, or I conclude with, that angle 1 is supplementary to angle 8. How the heck did I jump to that conclusion? Well, I didn't jump. We talked about 1 being congruent to 5 and 5 being supplementary to 8. because the congruency between 1 and 5, I can say, well, if 5 is supplementary to 8, then 1 is supplementary to 8. And that is called the transitive property. And we have proven. Okay, let's do one more proof. This proof's a little different. Same picture though. Oh, whoops. We want to prove that 1 and 7 are congruent. Okay. So again, I want to make a connection between line A and B, and actually have it highlighted already. So I think our first step is to make that connection and write that angle 1 is congruent to angle 5. And that's because they are corresponding. All right, so we connected line A to B, which is helpful. Now that we got from 1 to 5, we need to get to 7. How is 5 related to 7? Think about that for a second. Okay, 5 is related to 7 through vertical angles. And what do you know about vertical angles? They are congruent. Let's write that down. Step 3. Angle 5 is congruent to angle 7 because they're vertical angles. And yes, I did just write V and A because too many letters. Okay, well, if 1 is congruent to 5 and 5 is congruent to 7, we can finish by saying that 1 is congruent to 7. Why? Transitive property. Okay. Proofs can be a bit rough, so if you have questions about them, please talk to myself or your teachers in person. I think that would be the best way to talk through them rather than just through the computer. Okay, let's step away from proofs and let's just fill in the values of these angles. Okay, first things first, I noticed these little arrows. These two lines are parallel to each other, and then these two lines are parallel to each other. So everything is parallel to everything. Let's start filling things in. Okay, so I'm going to write a 105 right here because they're vertical angles. I wonder if I could lasso this 105 and copy it. Okay, we're going to see if this works. All right, so these two are vertical, okay, and here is a corresponding angle, so I can put 105. Oh, it worked. I can put a 105 right here. And then I have another vertical angle, boom, 105 right there. Okay, let's continue. I can fill in the other 4 values. The other 4 values we find by doing 180 minus 105, which gives us 75 degrees. 7, 5. All right. I'm going to lasso 75. Oh, maybe just a 7, I guess. Let's try that one more time before I give up. Lasso the 75. Yes. Okay. Oh no. All right. So this angle right here is going to be 75, and that's because they're vertical. Then let's correspond. This 75 corresponds with this 75. Oh my. And then we have a vertical angle right there. Okay. Because these two horizontal lines are parallel, we were able to fill this in. Now, let's fill in everything else. Well, if these two lines are parallel, I'm just turning my head. Turn your head with me. If this is 75, well then the corresponding angle is here, which means there's a vertical angle there. And that means there's a corresponding pair here, and a vertical angle there. And lastly, let's fill in our 105s. That's really all that we have left. There are no other values. 105 would go here, it will go here. Oops. It will go, no, a little over. I'm going to try to do it a different place since it doesn't really feel like doing its thing. Here, here, and lastly, there. Okay. Beautiful. Let's do one more. And scroll up. Okay, we're going to find the value of y. Now, this is a trapezoid. Something cool about trapezoids is that they are made of two parallel lines. The slanty ones are not parallel. If you think about it, those two side legs, they're kind of slanting towards each other. They should meet at the top eventually. Okay. This is going to help me visually, so I'm going to extend these two parallel lines. It's just going to help me see it. And maybe, oopsie doopsie, I hope it helps you too. Okay, so I have two transversals. I'm going to focus on this transversal first. We have angle 2x and angle x minus 12. They are on the same side of this transversal, the slanty line, that's the transversal, and they're interior. Something we know about same-side interior angles is that they are supplementary, which means they add up to 180. So let's solve. 3x minus 12, so I combine some like terms, scroll down, add 12 to both sides. 3x equals 192, which we can finish by dividing. X equals 64. Before I plug it all in, I'm going to solve for y, whoops, because I know I'll need to solve for y anyways. Okay, if you take a look at 3y and y plus 20, they are also on the same side of this blue transversal, and they're same side interior angles, which means they too add up to 180. Okay, let's solve this guy and we should be done. Oh, after we plug things in, of course. For y plus 20 equals 180, let's subtract that 20. For y equals 160, divide. Y equals 40. Okay, let's use those values to find all of the angles. Did I just say solve for y? Well, that's kind of lame. Let's find out all the values. I don't know why I wrote just solve for y. I must have not finished out my problem. Okay, so x is 64, so this is 2 times 64. So this is 128 degrees. X minus 12, so that's 64 minus 12, 52 degrees. Y, we got 40, so 3 times 40. This corner angle is going to be 120 degrees. And then we have 40 plus 20, which gives us 60 degrees. Now, you wouldn't be able to tell just by looking at this picture what all these degrees were, right? I drew this as a very perfect looking trapezoid. But if you look at those degrees, it is far from it. Definitely not a perfect trapezoid. I apologize, trapezoid, but we just can't assume things about you. Alrighty. I hope this was helpful. If you have more questions, please make sure to ask myself or your math teachers. Otherwise, have a wonderful rest of whatever time of day it is for you.